Hello, I am Dreise, and together with my partner Milton Ledesma, we are electromechanical engineer student representing the National Technological University from Paraná, and we are going to present our work. This paper is titled Offshore Wind Power, Its Possible Development in Argentina. At the present, there is a growing interest in renewable energy developing and exploring new technology with the aim of obtaining the highest possible efficiency and accessibility. These technologies have begun to have new applications, such as offshore wind energy, that take advantages of the resources and benefit by offering by the sea. Argentina has a stable and abundant potential for offshore wind power, but it hasn't developed as onshore wind power or offshore technology in some countries around the world. However, Argentina could establish itself as a strong producer in the South American continent through the objective called clean and affordable energy of the Agenda 2030 for sustainable development. This presentation will be divided in 4 parts. First, we'll begin with the analysis and characteristics of the Argentine coast under the following pillars: offshore wind potential and deeps and distant shore. Second, the different types of pillars that can be used in Argentina. In this stage of presentation, we are going to develop 2 types of pillars: the monopile assembly and reinforcing superstructure by tripod. Here, a comparison between the largest Argentine onshore wind farm with the offshore wind farm with the same dimension and taking into account the offshore and onshore wind potential. And finally, the economic and socio-political framework that is present in the country to determine the feasibility of this project. Regarding to the characteristic of the Argentine coast, it's important to analyze the energy potential and the restriction imposed by the coastal territory. About offshore wind potential, Argentina has 6,750 kilometers of coastline, and there are adequate climatical conditions to ensure that the wind resource is stable and abundant. The country has an average capacity factor, that varies between 50% to 65%, according to the study carried out by Capel Imperial College. In this study, areas that are competitive were excluded. An example are oil company and fishing area, but marine roads and protected areas were taken into account due to the great potential occur when the area is fully viable for its development. This study asserts that Argentina is a country where offshore technology can be implemented and that will bear both economic and socio-cultural benefit. Regarding to the deeps and distance to shore, this is one of the main criteria when selecting the foundation system for wind turbines on the seabed. For this reason, the International Energy Agency, together with the Imperial College, carry out an analysis of the deeps around the world that will be shown in the following map. The analysis here two types of results: shallow areas for deeps between 0 to 60 meters as color violet, or a deep area if the deep exceeded than 60 meters. Due to this, a structure rigidly connected to the seabed will be used. Now, two types of support structure we will develop. The first is the monopile assembly and consists of a steel pillar that can vary between 4 to 6 meters in diameter. This type of support structure can be embedded in the seabed, and the embedment length depends on the update load and the characteristic of the soil. 50 meters embedment is recommended to satisfy wind turbine stability. The monopilar assembly can be simplified supported on the seabed in very shallow areas by gravity. Second, reinforced superstructure have a tubular steel center section that is supported along its lower length by 3 tie rods that transfer axial loads to seabed and provide stability on the entire structure. Now, my partner Milton Ledesma will continue with the presentation.
My name is Milton Ledesma. I am going to develop the comparison between parks, onshore and offshore wind energy. The objective of this comparison is to be able to observe and understand the benefit of offshore wind farm over onshore wind farm. To make the comparison, the Global Wind Atlas program is used first and then verified by calculation. First, the onshore wind potential is determined using the onshore wind farm that generate the most power in Argentina, which is Madryn Wind Farm. This farm is located in Puerto Madryn in the province of Chubut and has an area of 62 square kilometers that is represented in this picture as a square. As you can see, this farm has a potential of 570 watts per square meter. In the case of the offshore wind potential, a park is proposed that is near of the Madryn wind farm and that has the same cover area of 62 square kilometers that can be seen in this picture as another square, obtaining a wind potential of 1,120 watts per square meter. In this way, it is verified that offshore wind farms generate twice the power than offshore wind farms. In the case of the verification by calculation, the wind power is Dreise, which is a mean of the air density times the cover area by the generator blades times the cubic wind speed. The area of the blades is developed as 3 times the length of the blade square. Finally, it is necessary to convert 1 kilojoule per kilogram equal to 1000 square meter per square second. To carry out the calculation of the power of the onshore wind farm, the following data are necessary. The air density is considered as 1.29 kilograms per cubic meter. The length of the blades is 60 meters and the wind speed of 8.6 meters per second. In this way, the data are replaced in the equation explained and 4,639 kilowatts are obtained, which is the power provided by a generator in the farm. And since the farm has 62 generators, the total power of the farm is 287,673 kilowatts. While for offshore wind farm, the wind speed is 10.57 meters per second. A power of 8,314 kilowatts is obtained for a generator. And for the wind farm, 534,107 kilowatts are obtained. In this calculation, 3 very details are important. The first is the fact that the power is double in offshore farm than in onshore ones. The second aspect is that there are 2 factors that can modify the power generated. They are the area of the blades and the wind speed. Third, an increase in wind speed generates most power than increasing the area of the blades. Okay, the objective of this presentation is to carry out an economic and socio-political analysis of the possibilities of implement an offshore wind farm in Argentina. To this end, an objective approach will be taken of Argentina's current situation. Taking into account the great potential of Argentina territory and climate, a large number of activities related to renewable energy can be carried out. In addition, the comparison offshore that offshore wind energy is a good option. From a political point of view, a few years ago, a development of renewable energy was started in Argentina called Plan Renovar. This plan is still under development and establishes the investment that the government will make for the different renewable energy. To carry out this type of project, work such as the design, planning, and maintenance that it requires must be taken into account. The cost of an offshore wind farm are twice expensive as on land. If the investment in the Madrid wind farm was $320 million, then a possible offshore wind farm requires approximately $640 million. The cost increases the value of the foundation structure used to place and the wind turbine offshore and the maintenance due to marine environment. Then the cost of this work and infrastructure exceeds what the Argentine government can afford, having a CPI of 51.8% for July 2021 and a poverty of 42% determined from the second semester of 2020. At present, the credibility and confidence of the country have been reduced due to political decisions taken, scaring off possible investors. Due to everything mentioned, this moment is not the right time to carry out this type of project. Possible in the future, condition will improve, and this type of renewable energy will be a viable option. In conclusion, this technology is a very good option to generate and develop renewable energy with a greater benefit than offshore technology. This is because the wind potential is double at sea than on land due to economic and socio-political aspect of the country. It is not possible to implement this technology at this time. However, knowing the situation in Argentina allow us to say that in every crisis there is an opportunity, and it's possible that in the future the political and economic measures of the Argentina state will accompany possible investors that help these renewable technologies grow and take on the importance of the desire in the country. These are the references used our paper and presentation. Thanks for your time and attention.